Hi, my name is Owen Mason, and this is Lab 1 on charge tapes. In this presentation, it will have an introduction as I go over the key ideas and setup of the lab. Following that, going over the computation models created in GlowScript, examining the results of the lab will follow, and at the end we'll do some discussion questions. The key ideas of this lab will examine Coulomb's law and the electric field of charged particles. And we will also be using the force of gravity in this lab to calculate the charge of the force. We're examining how a charged tape interacts with different objects. We created a piece of charged tape by quickly ripping off one tape over another one. This will create a charge on one of the tapes. First, we examined how this charged tape interacted with neutral objects, and in this we saw that it would always attract the neutral object. Afterward, we examined how the charged tape interacted with a known negatively charged pen. The two repelled each other, and this is how we know the tape are negatively charged. Afterward, to calculate the charge of the tapes, we measured the distance two tapes would repel each other when brought close. A few assumptions and data we gathered in this lab. First, the mass of the tape is very little. It is 0.001 kilograms per meter. Also, the length of the tapes are 0.21 meters long. From the setup we described earlier, the distance between the tapes when one started levitating was 0.0235 meters. The width of each tape, which we will use to figure out the total number of atoms and then therefore the XX electrons in the tape, is 0.0225 meters. And some general constants we use are the electric field constant of K, which is 9 times 10 to the 9th, the length of an atom, which is around 1 times 10 to the negative 10 meters, and the charge of an electron, which is negative 1.6 times 10 to the negative 19. And also the system of this experiment is only going to be the two tapes. We're going to gathering our data. I put all the data into a computer program called GlowScript. In this, we were able to calculate the charge of the tape, number of electrons in each tape, and the amount of atoms and the excess electrons in the tape. First off, we calculated the mass of the tape by multiplying the mass per meter times its length, and then using this, we were able to figure out the force of gravity pushing down, and from the force of gravity, we were able to set the force of gravity equal to Coulomb's law, and therefore solve for the charge of each tape. After that, by solving for the surface area, we were able to figure out the total number of atoms in the tape, and then by dividing the charge of an electron by the charge we calculated from the tape, we were able to find the number of XX electrons on that tape. Are shown below. The mass of the tape was 0.00021 kilograms. The force of gravity was very little. It was only around negative 0.02 newtons. The surface area of the tape was 0.004725 meters squared. This gave us a giant number for the number of atoms in the tape, and therefore a huge number for the excess electrons on the tape. The charge we calculated by setting the force of gravity equal to Coulomb's law for each tape was negative 1.12 times 10 to the negative 8 coulombs. This gave us a ratio of electrons to atoms on the tape around 6 times 10 to the 6 electrons. What if electrons had positive charge and protons had negative charge? What would this change about the observations we made and on the charged tapes? If this happened, nothing would change in the experiment. Both pieces of the tapes would become positively charged and still repel each other. Also, the tests earlier in the experiment would not change because the tape would still attract neutral objects and repel pens. A positive charged object would still attract neutral objects because it would still polarize the object attracting it. Why is it important to handle the charged tapes as little as possible? What happens when the charged tapes become in contact with your hands or other objects? It is important not to contact the charged tapes because the tape has many excess electrons. Electrons will transfer to a neutral object in your hand, so by touching the tape a lot, we will attract and remove all the excess electrons, causing the charge to disappear and become so little we won't even notice it.